Hey guys, welcome to Data Structures Hack. In this channel, we are going to focus on learning data structures and related problems in a pictorially represented fashion. Let's jump into today's video on stacks. Stack is a linear data structure where the operations are performed in a particular order. The order is something like last in, first out, or first in, last out. Let us see how it can be pictorially represented in the following example. For today's example, I am going to use coasters with values on top of it. Each coaster has a value on top of it, which represents the element that is being inserted into the stack. For the initial example, I'm going to assume that there is a stack over here which is empty. The emptiness of a stack is represented by -1. And -1 is being pointed by something called as a top pointer. Wherever the top pointer points to, we can decide whether the stack is empty or not empty. If the top is pointing to -1, that means my stack is empty. So we can understand that to check whether a stack is empty, all we need to do is see where the top is pointing to. If I want to insert a next value into the empty stack, say 11, what should I be doing? I should be using an operation called push. So if I say my stack dot push 11, then the top would start pointing to 11 from -1. If I want to see what is the value at top, all I need to do is use another operation called peek. If I say my stack dot peek, it is going to currently return the value 11. If I insert or push another value into the stack, say for example 8, my stack dot push 8, then top would now start pointing to 8, and if I do peek currently, it is going to return 8. Over here, I am going to assume there are stack which is a fixed size and dynamic. If I make this stack a fixed size stack of size 3, what would happen is the example which I'm showing next. Next, I'm going to push another value 6 into the stack. If I want to insert or push another value 4 into the stack, what is going to happen? The stack is simply going to throw an exception saying it is full and it cannot take another value into the stack. So this is a fixed size stack. But in case this stack was a dynamic stack with size 3, what would happen? It would take the element 4 into it and it would just increase the capacity of the stack to double of whatever was initially given. So if it was 3 initially, then it would make its size as 6 instead of rejecting the element that is coming in. If I want to delete the element from the stack, I can only delete the first element by using operation pop. When I delete the first element by saying my stack dot pop, I'm gonna remove 4 and the top is now gonna point to the next element, which is 6. And it goes on. If I go on and pop all the elements from the stack, now I have removed 6. Next I'm gonna remove 8 by popping and 11 by popping. And if I do a pop now, what is gonna happen? It would simply say the stack is empty and no element can be popped. So this is the pictorial representation of stack. And in the future videos, we are going to see how Stack can be implemented by arrays and linked lists. Thank you so much for watching the video.